Hello guys, welcome back to another video of Dylan Hacks. Today we have special guest on this table. This is Tektronix DPO2014 digital phosphor oscilloscope. Now, I picked this up from eBay for around, I think, $300, and it has a problem. So let me show you. So when I plug this thing in, just show the white screen. So when I try to turn off and then turn it on again, it would just show the white screen. Now I will try to repair this thing, and spoiler, I actually tear this thing down and do some diagnostic before, so I kind of narrowed down what's the problem, but I will do the whole tear down and guide you through anyway, and hopefully that I can fix this thing. So let's tear down. Now, to take apart, you need one of these. So we start from the back. So this is the back of the unit. We have both screw right here. We're gonna take this apart. So just put this thing down. I actually loosen up some of the screws so it's easier to take out. And this thing will just come right out easily. And this is inside of the unit itself. So here we have the DC fan right here blowing in the air, and so I'm not sure if you can see that there has some sort of like corrosion inside. That could be because of the air is blowing in, so they have some sort of like humidity concentration around here. And here is the power supply section. We have a power supply from Emerson, and let me flip it for you so you can see the voltage. This thing is quite heavy, not sure if you can see it. We have the 13 volt DC output, we have 3.3 volts, we have 5 volt standby, and 5 volt and negative 5 volt. Not sure if you can see it, but yeah, it's pretty hard to see. And next we're gonna tear this thing down, and we're gonna remove some of the screw around the unit. So let's start from here. We have 4 screws right here. Take this out. I'm gonna use it to keep screws. There's 2 screws down here. So out of the 2 screws down here that you have to take it out. Oopsie. And then there is 4 screws here, and you have to also take this like ground connection. Start from this corner. I forgot to mention that you probably need like a longer screwdriver, because there were some places that you have to like reach in very deep. So I actually have like 2 screwdrivers. I have this like more sturdier one, and I have like this flimsy plastic so I can reach in, but this is like too weak and it cannot unscrew some screw because some is just too tight for this plastic. So you just want to have one like a very strong and like a long screwdriver. And another 2 here. Unscrew right this way. I'm not sure if you can see it. Just make sure you can see it. It's also helpful to have like a magnetic at your screwdriver bit, so it can pick up the screw for you. Okay, then you have to disconnect this cable, and I have to remove the ground connection. Around here you have to disconnect the fan connector, okay, and then of course the main power connector. Take some force, and before you lift this thing up, there is USB connector right here that go down, so you have to be like very careful in taking this out. Sometimes it's just stuff like that. Oh, my bad. There's two screw in here too. Two screw in here. So as I told you earlier, you're gonna have to use like a long screwdriver to get this thing out. But something like this is just fine. But you're gonna, you know, space is pretty tight, and you gotta try. So I think you can lift this up, yeah, and as you can see there is like a USB connector right here, and we can set this thing aside. Now we finally see the main board of this unit. So here we have a bunch of stuff going on. So here on the right you have power input here, and you have like several switching power supply. So this one is a synchronous buck converter, so you can get like 1.8 volt, 1.2 volt to support all the digital logic thingies, and also they have some I believe that the analog voltage is come directly from the power supply unit. Previously the switching power supply, that AC to DC thing, and then distribute through the board, and we're gonna see some part that they have like a regulator. Okay, so let me start from here. Okay, so this is the Freescale / NXP, the MCP870. This is like a power PC microprocessor. So this one doesn't use ARM, so it's a bit old, and also I heard that this thing is pretty slow, but I don't really care anyway. And two of this is like Intel Strata technology. I think it's NOR flash memory. So here you have firmware to boot this thing, so I will show you the boot log later. And next to it is the Altera. I think it's doing like a glue logic and something like that. On top of here we also have like this is the USB controller. So it is ISP1761. It's from NXP. It's because we have like a USB host and USB devices here. Okay. So next here we have the display connector. This one is made by Amphenol. I wasn't sure which part number was these things. You're gonna look that up maybe later. And we here at the main section that made this oscilloscope. So this is 4 channel, and this split into 2 parts, and as you can see we have like a differential pair running. I'm not sure if you can see it. I have to bring it closer. You have some like wiggly length matching things. So we have a clock distribution. Down there we have 66 megahertz oscillator and PLL, and next to it we have like an ECL fan out clock buffer, and right here we have like a high speed comparator from Analog Device. Two of this thing is the ADC. It's kind of look like a custom part from National Semiconductor, but actually this is the ADC 08 D1020. I think is a dual 1 gig sample per second ADC, and we have 2 of them. So each one of these has 2 channels, so we can support all 4 channels. And up here we have 2 Tektronix custom ASIC. So what it is that is basically acquire the data from the ADC, get into either do some processing, and you saw that they have like a server memory around here, and this memory actually shared with the main processor right here. So they can connect using some sort of like memory bus between these two guys and this processor. So what happened is that when you have analog signal coming in from the analog front end, it was digitized by the ADC and then sent out to this thing to process the data. And this guy having like a maximum 5,000 waveform update per second, compared to this LaCroix wavejet oscilloscope that doing around 3,600. So this one is a bit, faster. Anyway, so here we also have like a LED to show some sort of like boot code, error code, status code, whatever. I will show you that when this thing boot up, it's just showing number 8. It's like something stuck under reset and doesn't start, and it's just done output like meaningful code. And here on the left we have the connector to the front panel, and I think just that's it for the entire oscilloscope. There's not much here. We have the RTC clock right here, and I already checked that the battery still have some juice in it, 3.0 volts bang on. So let's try to power this thing up, and we're gonna diagnose to see what's wrong with this unit. And this is the setup of the test that I'm gonna do. It's quite messy because I have very small desk, and I have to put the display unit in the front panel around here, and the mainboard section here in the middle. We have power supply around there, and it's live right now. We connect to the hut, and I have this oscilloscope, so I can show you some waveforms and things in there. Okay, so let's first start from measuring the voltage. So let me, not sure if the measurement part here. Let's see if we have measurement of vertical. I'm not sure if we use RMS. Okay, so let's probe something around here. So we have this that holds up the ground. Okay, so we have several test points. I have to pan the camera around, and I cannot zoom. Sorry, I cannot zoom, but there will be some test points around here that we can probe, and I think I have to switch the lens. I'll be back. Alright, so I switched the lens. So here we have several test points that we can check the voltage. I think I'm gonna use multimeter because I think it's easier to show you on the screen. So right now the unit is plugged in, but it's powered off. So here I have my DMM. I'm gonna put it there so you can see it. So let's turn the unit on and see what happens. So as you see, there's LED lights up, and then you saw that 7 segment just light up some nonsense. Over there is 2 LEDs, and actually around there's LED too that I have to, Okay, so I have to measure the voltage. So let's start from this around here, this corner. So let me get some grounding. So here we have the P 3.3 volts. So this is a 3.3 volts, and okay, we got 3.3 volts. Pretty nice, pretty neat. Next is the P1R9VA. So this is 1.9 volts for 1.9 volt for analog system, and we got around 1.9. Not bad. Next we have 12 volts, and we read 12 volts. Good. Next we have the digital voltage rail. This one is 1.8 volts. Okay, so we got 1.8. next one, sorry, this one is actually 1.2, not 12. 12 should be this one then. Yeah, and this one is 5 volts, and this one is gonna be negative 5 volts, so yeah, a little bit off, but that's fine. And way around there on top we have another 5 volts. This one is standby voltage, and we also have the digital voltage for 3.3 volts, which looks okay. And we have to move to next section, which is up there, so I think I might have to move my camera. You can see. Okay, so here we have 3 voltages. The one on the top is negative voltage, 1.6 volt for analog system, and one in the middle is also 2.6 volt plus this one is a positive voltage for the analog system, and the third one here is the 2.5 volt for digital system. So let me probe and show you what happened. So if we probe the negative 2.5 volt, it's not focusing. Yeah, you can see it's 2.5. yeah, but if we probe other things like this one, we 2.6 volt and the 2.5 volt for the digital, as you can see, this just plain 0. And I'm gonna move to this section and show you what happened around here, that why is having this problem. Okay, so we're gonna focus on this section, and I'm gonna do some probing around. So I'm not sure, I have to put the multimeter somewhere. It's pretty hard to just, maybe you can just put here. Okay, so we have negative 2.6, right, and positive 2.6. This two is for analog, and another one, that 2.5, is for the digital. But as I show you that the only negative voltage was present, but the digital voltage here and the positive of analog was gone, and I think I have to turn this off. So let me show you that. I'm gonna change to the continuity check. Okay, just make sure that this thing is turned off. So if I were to check the continuity, let's say we start from the negative voltage, we have this regulator here, which is like I will put the part on screen. It is the negative voltage LDO regulator, linear regulator, and here is the output. And what takes in this is that we have negative 5 volts, which way off the camera, and it's actually connected to this part, but I wasn't sure. I have to check again because it might be another, like, filtering and something like that. And this one is grounded, so if I remember correctly. And they have some sort of like corrosion, oxidation, because the air is blowing in here directly, so there's like lots of dust and things. So if we move to the analog voltage, the positive analog here, we actually have this section. So there is 2 regulator, like a linear regulator, that I am yet to find the part number for this. And we have this, right, and we have this capacitor things here, this is coupling. And if I were to probe around here, this is the output of this chip right here. I'm not sure you can see it. This chip, this one here, which is outputting the positive 2.6 volt for the analog system, and next to that we have this thing, which is outputting the 2.5 volt for the digital system. And as you can see, we have this 2 chip next to the capacitor, and right here is very big, like a plane that runs through this IC, and this IC is actually MOSFET. So this is in-channel MOSFET, and they're kind of switchable on off. And I actually checked the circuit, which is on the back, and the circuit that this is basically powering sequencing. So you have the power coming from another rail to trigger this rail to turn it on. And if we trade another side of the MOSFET, it's actually coming all the way from 3.3 volts, and I have to move around here. It's coming over here, so this 3.3 volt go that way, area of the scope, and we have the linear regulator dropping it down from 3.3 volts to 2.5 for the digital and 2.6 for the analog system. So again, let's power this thing on and see what happened to the MOSFET and everything around this section. So now the unit has been powered on, as you can see. I will put this thing back again so you can see my measurement up here. So what I'm gonna do is that I'm gonna probe the signal on the gate of this MOSFET to see the voltage, to check the voltage and what happened here. So before that, on this side we have inputs of 3.3 volts, right? And we should have 3.3 volts here on another side. So I think this side is source and this side is drain. I'm not sure, I have to check the datasheet again. But if we probe, as you can see, we only have 0.7 volts. Yeah, so you cannot see decimal, it's a reflection. Alright, only 0.8, 0.7 volts. And if I check the gate signal, as you can see, it's only just 1.8 volts. And this MOSFET needs something like 10 or 12 volts to fully turn the gates on, meaning that the MOSFET just barely turns on and is operating in, like, I don't know what they call linear region. I think it's not fully turned on, so we only get 0.8 volts. That's why there is no like voltage here at all. So we're gonna flip the board on another side and we're gonna see what happened. But before that, there actually has the like a same MOSFET on another side here on the other side. So we can measure it and take a look at the gate voltage to see how much to turn the MOSFET on. So I'm just gonna move this around here, and as you can see, this is the FET itself. So you're not sure, you cannot see. I have to move the lights around. So let me measure the gate voltage. As you can see, the gate voltage is 12 volts, and here we have like voltage going in and voltage coming out. It's 3.3 volts. So in this case, this MOSFET was fully turned on, so it's be able to conduct 3.3 volt through like a closed switch, which is not what happened with this part. So yeah, gonna flip the board and take a look. Okay, so I moved things around a bit, and this is on the back side. Okay, so the setup is that it's pretty hard. As you can see, I have to like twist things around. And but anyway, here we're gonna take a look at the section where it drives that MOSFET. So let me grab my multimeter. I don't know where to put it this time. I think we put it here. I think. Okay, you can see that. Great. So let's power this thing on again. Trust me, this thing was powered on. So you just check the negative voltage, and it's there. So the system powered on. I don't have like a smaller tripod. I want to have one so I can show you a little bit closer on this section. So around here you can see there is like teeny tiny transistor. This is the NPN transistor that was used to essentially drive this MOSFET, and the drive signal is coming from the 5-volt rail. So basically it's doing like a poor man power sequencing, and I'm gonna try to measure that and show you. Let me pick some ground points. Okay, up here. Okay, we got a good ground points. So we have like a very tiny resistor here, and if we measured it, it is 13 volts, and this is where it came from, the 12 volts, and it's used to power the MOSFET. And if we have check this signal, this is 1.8 volts. So basically here we have 1.8 volts. So this thing is quite weird. I don't know why they doing the way that they have like the transistor. It doesn't go into ground, instead it's going to 1.8. So it's like 12 volt potential and then 8 volt 1.8 volt potential different. I don't know, some voodoo magic about analogs. I don't really use BJT transistor. So this is the NPN transistor that they use to drive the MOSFET. So let me check. I can show you here. This is the base of the transistor. So we got 2.4, 2.5 volts, because this thing is actually derived from 5 volts, and they have like a resistor divider network, blah blah blah, with some little capacitor coupling. And here this is the actual signal that drives the gates. So it's just 1.8. The gate just don't want to turn on because the VGS is too low, and on top of here is the 1.8 volts. So yeah, so what I'm gonna do here is that I'm gonna try to replace this transistor, and let's see what happens. Okay, so now I put everything back together. I mean, the setup, the power supply, and the front panel thing. So I'm gonna wish my luck and power on in 3, 2, 1. I mean, okay, it seems to power on, and the LED just stay there. Not sure what happened. Then we check the voltage. So got 3.3, got 1.9, got 1.2, we got 1.8, we got 12 volts, got 5 volts, negative 5, we got standby 5 volts, and we got 3 volts. And here we on this side we got negative 2.5. And okay, we seems that we don't have the 2.6 again, and again we have 0.8 volts, and we have 3.3 on this side. So, and the gate's voltage is again 1.8. So at this point, let me try something. So let me I think I have some jumper cable. Let's see what happens if I jump 3.3 volts. Nothing happens. Let me check again, see what happens. Okay, this one came up to like 1 volts, and this is like discharging. So another thing that we can do is that we can replace the MOSFET, and I actually bought the MOSFET, so let's replace the MOSFET. Okay, so I have to cheat a little bit. I just use the solder wick to budge and jump the MOSFET, and I'm gonna power on. I'm gonna see what happens. I wish nothing goes wrong. So here we go. Let me plug this thing in. Okay, it seems to stuck, and let me check the voltage. Well, now we got 2.5 volts, and we got 2.4 to 2.5, and we got negative voltage. Alright, and okay, so wasn't sure what will happen next, so let me put everything together and see what happens. Look at that, it shows some light. Okay, now so I just plug it in and let's power on. Let's see what happens. Okay, I have to take the phone off. Yeah. Take quite a while. Some got this. Oh, look at that! Look at that! Look at that! Got some lights. We got some lights. And oh my god. Okay, I will try to put everything back together and let's see what happens. Alright, so I partially put this thing back on. As you can see on the back, there's still open case, and put all the backlights and everything. So let's cross the finger. It's quite hard to put it in. Here we go! Yes! We got the logo! Yeah! Yes! We got the logo! So let's see if this entire thing boots up first. See if we get into the application. I mean, because this thing actually runs Linux, by the way. You start off with the U-boot bootloader, and then it boots to Linux with BusyBox. So let's see what we have here. It's gonna take quite a while. I've heard that this thing takes quite a while to boot, compared to something like my WaveJet that I can just press the button. As you can see, yeah, my WaveJet took something like 4 seconds. This thing takes like 4 minutes. Oh! 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 Here we go! I want self-date pass! Yes, sir! Okay, so we got single button working, run, stop. Let's see what we have like. Okay, let's see what we. Oh, okay. One panel working. Okay, we have DCAC full bandwidth, 20 megahertz. We can set probe attenuation. We can we have 20x? Yes, we can have 20x. And talking about 20x, on the next video I'm gonna take a look at one of these probes that I designed. Okay, great. So let's turn on other channel. So Okay, we seem to have problem with encoder, I think. Yeah, look at that. Yeah, it's quite jumpy. I think we have to take the front panel off and see what we got. With horizontal, we can change horizontal per div. Okay, great. Position detail. Okay, we got the 1 meg points. Utility, let's take a look. We have what we have display. Okay, we can change backlight intensity. I'm going to set to low, and gratitude set to full. And we have I/O. We actually have the USB, and we will use this for we have this calibration, factory path. We have signal path compensation. Last running November 2008. Holy crap, this thing like almost 2 decades ago. You can go to the trigger menu. Right now it's in normal. If we go to this, okay, can change to, of course, we can run. Right now we okay. Yeah. Levels go crazy. You can change, like as you see, it's quite jumping around. Let's see what we got. Okay, the voltage per division knob looks good. The one that gone bad is the fine adjustable knob, and trigger seems okay. Yeah, we have auto on trigger, roll, slow. Trigger, we have pulse width, run, logic. I don't think this is the latest software version. Let's check utility. We take a look at the about. Okay, with version 1.03. I actually have a newer version in this flash drive. Let's actually want to see what happened. We have like a text erase something. We have this part. I really like the wave inspector thing, but the knob is missing. Okay, but this outer knob is working, and the inner knob is working too. Okay, great. I think I'm gonna 3D print for this guy. That's great. We have cursor, of course. I think it's actually this math. We have like FFT, dual waveform math, FFT. Oh, it doesn't even have the FFT built in. It doesn't even have FFT. We can set the label. That's great. And oh, right now it's in the run triggering. We have set up in whole video. We can actually use like a logic triggering, and we can trigger with bus. We have like edge triggering. It's stuck in zoom right now. We can, I think, in a one kick sample. It's pretty slow, as you can see. If we change 200k points, yeah, I love that. We have average, a waveform display, we set persistent time. What else do we have here? We have save and recall menu. We have like default setup. Okay. Yeah, the slight encoder just go crazy. We have bandwidth, time scale, offset, position, deskew. Great. So let me try to upgrade the firmware. So turn this thing up and turn this thing on again. I don't know if this detects the firmware in my flash drive. Pretty slow actually. Okay, for some reason it doesn't detect my USB. So let's go to here. I don't know if we have like a USB. We have like error logs. So this thing works up to like 2014, 2020. I mean, maybe the clock was drifted. Like date and time. Okay, it went back to 2004. That's just the kickstand. No, sorry, just kick this. Never mind. Anyway, we can try. We have like self-test. We can try. Okay, we can check. This thing powers up 359 times. Check the CPU. Pass the display. Pass. Position. Take quite a while. Seem to doing something. Okay, pass. Great. It's complete. One thing that I noticed is that it seems that it doesn't detect my USB flash drive. Wasn't sure about them. Media is missing. Insert appropriate media. I don't know how do I have to like format this guy or something. Yes, calibration. someone put in the reference waveform. That's quite big waveform detail. So okay. Oh, we can hide everything. I mean, because the display is pretty small. Okay, let's run the signal path calibration. Approximately 2 minutes. Let's see if we pass the signal path compensation. Yeah, it doesn't show, like, for example, on the TDS3000 series, it will show you what happened in the background, but this one doesn't show. It also happened with my wavejet. Somehow it just doesn't show like the process that's going on. Actually, I picked this one up because I've heard that you can actually upgrade this thing to 200 megahertz using nothing, just command line. You just plug in this thing to your computer and use like Tektronix VPI. No, it's not VPI. What is it called? Like Tech Open Choice software. You can just send the Skippy command to this thing, and it will just turn itself into DPO2014. Actually, you can change to the MSO series, but I don't have, the hardware. It's taking quite a while. Okay, so we got compensation error. That's not good. That's not good. Okay, that is a lot of that's a lot. A lot of DC offsets. I think it's software locked. I think we can unlock that, but it's probably require like software modification. Okay, so it seems that the offset, signal offset looks, I don't know. You can use like this filter. Look at that. Yeah. DC offset look quite crappy. I mean, but not as bad as first channel. You can turn off. How we turn this one off? Filter view. I don't know how to turn this thing off. We also have like intensity grading, of course. You can change the gratitude. No. I'm not gonna touch that. how to turn this thing off. I don't know how to turn this thing off. Okay, so okay, so this look good, but the sprint button doesn't work. I don't know why. Maybe because of they say media is missing. File utility. Oh, yeah. Huh? Removable media. Select button to open. Okay, it doesn't seem to see anything, and I just remove the media. Hello? Removable media? Could it be like internal drive? Okay, that's it. I think it's working, but it's failed signal path compensation. Maybe we can do something about it. Maybe we're gonna try to run it again. But yeah, I think it's a win for this repair. Thumbs up. Okay, so I reformat my disk. It seems that it cannot comprehend 32 gigabytes. So I just create like a single partition of something like 3 gigabytes, and now I put the firmware into this thing, and I'm gonna turn this guy off, and let's see if we can upgrade firmware. Now the latest firmware is version 1.56, but the one that I have here right now is 1.3 something, because I just want to make sure that I can hack this thing to the DPO2024 before we upgrade to the latest firmware. And let's see if it will pick it up to update the firmware. Because previously the drive seems to not it doesn't recognize the drive, but now I checked it and it's recognized, and just want to see if they would be able to update the firmware. If it cannot, I think I have to buy another flash drive. Please just update firmware. I don't want to stuck in this old 1.03 firmware. No, just get into the firmware. Okay, anyway, we can take a look here in this menu. Okay, just press default setup. So now it recognized the drive. As you see, it found the firmware, and we cannot upgrade from here. Yeah, for some reason, I don't know why it doesn't pick up the firmware image. Maybe I can try to power on again. Or do I have to pre-power on the flash drive? Maybe the start time of the flash drive is too slow. Okay, yes, here we go. The firmware upgrade is in progress. I wish I can actually hooked up the serial, but now I don't have the USB TTL to serial things. I will do it again when I upgrade to 1.56, so to just save things as reference. And upgrade takes about 10 minutes, So I'll be back after 10 minutes. Okay, so we say the firmware upgrade is complete, and they said to continue remove the media and cycle the oscilloscope power. Okay, this power cycle. So what they say to remove. Okay, and then power off, and then it's power on again. Okay, we got boot screen, which is the good news for this. And let's see on this newer firmware version. It's gonna take a while. I have to have to clean this up. It's quite the condition is quite filthy. Also, I have to take this front panel and replace all the knobs. Some just like the fine adjustment. And the position knob, this one is also pushable. Okay, so here we go. We booted. Firmware upgrade has successfully complete. I'm not sure you can read that. Push menu off to proceed. Great. Let's go. What we have here. Because we still have that crazy offset, we can try to. Okay. Now we on 1.35. 1.35. Let's see what we have. Say in the display. I want to use low. Okay. I/O. Of course, I'm gonna try connect to computer. Calibration. It still say pass because it's the last calibration. Self-test. Yeah. You can retry that again, but I'm gonna do that again later. Okay, so I think now we would have FFT. Okay, you can use blah blah. Okay, we now have FFT, and we can sort from channel 1, and we have like different window, and we can set the like center and span, and we have like gating indicator, which I think I'm not sure where the indicator somewhere. Did you see that? Okay, we can turn the mask off, and the bus, of course, I'm gonna make the module that plug in here. I have bought some, the SIM card slot that we can modify to put into this module. But anyway, that's for later video. And file utility, of course, we don't sign things. We have like, sadly we only have like 2 reference. I don't know why this is too little. Maybe the flash or something. And on each channel, we have cursor. This one looking okay. This button is also looking okay. What happened? Why is that? Why when I... Okay. I think it's like you have to... You can use like fine. Great. I think it's also we have to do with this. So like I've heard that if you like doing start to like work again, you have to kind of like get this thing like you have to like exercise. It's quite different. The level is okay. It's very responsive actually. It's faster than my LaCroix in some way. Trigger, we have auto triggering. See, we can have row mode. Yeah, okay, row mode. Not bad. Acquire. It seems like a position. Set the port length. Some oscilloscope have peak detect. Okay, so this one doesn't have peak detection, but it has like filter wheel instead. So you can, okay, so to turn off you just, yeah. Which I want one things, if we can, I love to use delay like this one, because at my company I use MDO3000, and when I come back to this, it's quite similar actually. We have waveform display and we have like persistence. We cannot turn that off, I don't know why. We got XY display. Oh, yeah, I don't know what is that. Okay, I never use XY display anyway. Set time and date, I'm gonna do that later. Okay, we have been here before. Error log. Calibrate. I think there have been like past attempt on calibration. They actually wait clear error log, but I'm not gonna do this now. So okay, I think it's a win, repair, win.